So good afternoon, everyone. My name is Alessandra Latorre, and I'm very glad to be here today representing Peru. Our study was based on the in silico design of quercetin derivatives with potential dual inhibitory activity against GSK3B and CDK5B25 for the treatment of Alzheimer's disease. There are over 55 million people living with dementia in 2022 based on the National Institute of Aging. And even if it's multifactorial disease, we will approach the amyloid cascade hypothesis to develop our project. So I would like to highlight that we are Peruvian students. For our hypothesis, we will cover the hyperphosphorylation as a histopathological hallmark for Alzheimer's disease. The two major biomarkers for Alzheimer's disease are senile plaques made of beta amyloid aggregates and neurofibrillary tangles of hyperphosphorylated tangles. So as we see, kinases are closely related to the overaccumulation of beta amyloid, and our strategy will be to design inhibitors to decrease the overproduction. So our proteins are GSK3B and CDK5B25 based on literature review, because their activation or over high activation is related to the overproduction of beta amyloid. And as ligands, we will present you some flavonoids modified in the carbon 8 position, and our base skeleton will be quercetin. So our objective is to design in silico carbon 8 substituted quercetin derivatives as dual inhibitors for both kinases using a toxicological and structural bioinformatic approach. Here I present you two of the flavonoids used as kinase inhibitors, and historically flavopyridol was the first one a cyclic-dependent kinase inhibitor, so that's why we will use it as a drug of reference. And even if there are scarce studies with substitution of flavonoids in the carbon 8 position, they have shown to be great candidates for inhibitors of Alzheimer's disease. So our workflow was based on the design of 613 biososters using Swiss Biososter and Marvin Sketch. Our screening based on kinase activity criteria, toxicity, and Lipinski rules was made on Swiss ADME, Drug, and also Data Warrior platform. And we optimized the 22 biososters in Avogadro. Our proteins were cleaned and prepared with Chimera and Pymol. And the docking experiments was made on two platforms with Autodoc4 and Autodoc Vina, highlighting that Autodoc4 provided best results. We validate our best post for the ligands with post and rank. And finally, we analyze with Discovery Studio all the interactions, and we will present you the best two biososters as candidates. So here I show you a graph where we can see the activity criteria we use and the inhibition of kinases and also the expression of the ApoA1 gene that is related to Alzheimer have proven to be good for all the 22 compounds, and they overcome a threshold of 0.44. And also we present you the values for the drugs of reference in the right part. None of the 22 compounds will provide some toxicity activity, and none of them will break more than 2 Lipinski rules. But if we see the TPSA value, it's higher than 90, so they will not be able to overcome the blood-brain barrier, and we will need to be done a drug delivery approach. I present you here the 22 compounds with the binding energy of the best poles. And I have highlighted the drug of references because the two suggested inhibitors will overcome the binding affinity. Also, we use redocking with Autodoc4, and we see that the values are higher and close to 1, so are good models. And here I present you the basic interactions, which are the most important for QT115 with GSK3B, and also for QT94 with CDK5P25. So based on that, we can say that our models are good candidates, and the carbonate substitution was successful for present dual inhibitors. And well, the two compounds are highlighted, right? So our further steps will be making a QSAR model, molecular dynamics, and also drug delivery approach, because it's needed to confirm our work. I would like to thank the team and also the organizing committee for inviting us today. And if you have any questions,
Владимир.
sorry, I cannot.
Alessandra finished her talk.
Probably I will continue and finish. So the questions for you from Kunal Roy. What do you mean by bioesters?
Yeah, bioesters, as I can show here in the picture, are molecules that were produced based on modification of a specific part of, well, in this case, the flavonoid quercetin. So we took the air as representative. It could be a functional group, or it could be any substitution like a methyl group or others. So we proved these molecules if they were yeah.
Unfortunately, not everything was perfectly here, but okay. Let's pass to the next question from Dmitry Osolot.
Yes. Do you hear me? No.
Yeah. Okay. So you can continue.
Okay. It was something strange. I don't know. Yes, Dmitry Osolot. Alessandra.
Yeah.
Are your findings translatable to clinics, given that flavonoids sometimes enter clinical trials, but are rarely approved?
Yeah. Yeah, we hope so. Based on that, we will try to do an in vitro analysis, and also to cover the drug delivery to overcome the blood-brain barrier. But yes, we will send this as a candidate for an in vitro.
Yeah, here's the comment of Dmitry Solotkin. GSK free beta was the topic of his PhD thesis 10 years ago, and I was his supervisor those time. Okay, another question, Dmitry Shulga. Do you observe hinge region interactions for the obtained complexes of kinases? Oh, looks like sound disappeared. I don't hear. Do you hear me?